Hello, everyone. Hopefully you had a nice lunch. I'm Jose Torres. I'm a Spark contributor, a software engineer at Databricks, and the tech lead for the continuous processing project. So basically, there's a fast version of this presentation, and there's a slow version. I'm going through the fast one first. The fast one is continuous processing is a new streaming execution engine within Spark structured streaming. It doesn't have any microbatches. It has very low latency, like on the scale of 1 millisecond end-to-end latency for the simplest queries. And like I mentioned, it uses the same Spark SQL structured streaming API as streaming does today. That's the fast version. To go through the slow version, there's going to be a lot more history lessons here. So the first version of streaming that we did in Spark was known as D streams. A D stream basically represented just like a sequence of RDDs where each RDD that you computed was one microbatch of the query. So there were significant limitations to this API. One was it was similar to RDDs in that it wasn't declarative at all. You specified exactly what transformations you wanted to take place, and Spark would handle like distributing them, partitioning them and everything. But there were no opportunities for optimization in the database sense. Spark couldn't come in and say, well, I know an equivalent transformation that'll do the same thing but be more performant. It just couldn't happen at all. It was also only available in Scala and Java because the RDD objects are Scala and Java objects inherently. Checkpointing had to take place as a complete snapshot, basically the same thing as RDD checkpointing, which is fine for some kinds of aggregates. The weakness comes in when you have large numbers of groups and only a few of them are updating at any given time. Basically, the cost of taking a complete snapshot each time becomes prohibitively expensive. And finally, there was no kind of event time support, so it's very difficult to properly deal with late or out of order data. Yeah, it was possible to do only through like basically implementing the entire custom logic of your own. It was really difficult, and very few people actually did it. So I think it was Spark 2.0. We introduced structured streaming, which is a kind of different abstraction. Instead of having a sequence of RDDs which glued together make up like the abstract stream, the basic abstraction is the incoming stream of data, and the stream is like conceptually in the API. It's what we say is a virtual append only table. There's no actual table there, so that's a bit of misleading terminology. But we've struggled to find a good way to explain it. Basically, the idea is you have new data that comes in, but that's separate from what your query is. The actual query you write is exactly the same as a batch query you might write over the same data. It uses the same API. You get the same answer over the same set of data. Yeah, basically, there's a lot less you have to do to think separately about streaming. It's a batch query where there's more data that comes in from time to time, so it doesn't ever. Yeah. I guess this is just an illustration of the virtual append-only table. Again, there's no like actual table that represents this. This is just like how when you're using the structured streaming API, you kind of reason about what's going on. So in the transition to structured streaming, we picked up a lot of nice things. We have the data frame and data set API. Again, it's the same API as you would use to write a batch query in Spark SQL. You have integrations with SQL, Python, and R. You're no longer limited to just Java and Scala. The aggregation state is more scalable in the case I mentioned. You don't have it doesn't take complete snapshots of all of the state every time. And we introduced event time support. Although I think that was in a later release, but yeah, we introduced event time support so that Spark can now like cleanly deal with it with out-of-order data. Yeah. So because of that abstraction, that leaves the question open of how do we actually execute a structured streaming query? And the strategy that we originally implemented and that's currently implemented today is known as microbatching. Basically, what happens is in some configurable period of time, Spark goes to the remote data source and says, "All right, is there any more data available to me? If there is, please give it to me, and I'm going to feed it into this query, and it's going to do the thing. If there's not, I'll just try again later to see if there's more data later." The advantage of that is that it maps very cleanly to batch execution. Basically, a micro batch executed streaming query starts up a series of individual Spark jobs, and each of those Spark jobs is just like a normal batch job. There are a few like streaming specific operators, but there's nothing fundamentally different about it. It runs and gets executed exactly the same way. I moved that slide too early. But anyway, the weakness of microbatches, weakness is a strong term. In practice, we find that this normally doesn't matter, but microbatches do introduce an inherent latency. The absolute minimum latency you can get for record, because Spark has to like schedule a job after it's aware that new data comes in. The minimum latency you can get is the time it takes for Spark to schedule a job, and in most clusters that's a significant amount of time from a system's perspective. It's like 100 milliseconds or so. And in practice, if the Spark jobs themselves take a long time to run, that increases the latencies you can achieve even further, because while a job is executing, Spark has to wait for the job to finish, then see if there's new data, and only then can new data come into the system. So the idea behind continuous processing is, what if we didn't do that like weird little round trip there? What if we just had a Spark job that was like long running indefinitely until you shut the streaming query down, and that job can just like continuously pull the remote source directly to get new data. So as soon as a new record comes into the remote source, it can immediately flow to Spark, and if the Spark task that it's responsible for it isn't actively processing another record, it can immediately start processing it. And when you do that, you get much lower latencies. Like, we benchmarked it at between like 0.5 milliseconds and 2 milliseconds for the simplest queries. But basically the idea is you're processing these records as soon as Spark possibly can. Yes. So doing this. I like gloss over this before. It introduced an additional complication because microbatches kind of do two jobs. One is they like get the data into Spark and process it, but they also deal with checkpointing. Basically, at the end of a microbatch, Spark can like pause for a second, but not a second, for a short amount of time. Spark can pause and say, all right, that batch is done. I know what data that batch contained, so I can like write to the commit log. This batch is definitely done. I'm never going to need to go back to it. With continuous processing, there's no like single point where that happens, and in fact, the logical execution of the query doesn't ever really pass back to the driver to even have that. So we have to. In order to make continuous processing work and be like fault tolerant, we have to go back in and add this checkpointing. So the way we do that is with an adaptation of well-known distributed systems algorithm called the Chandy-Lamport algorithm. Conceptually, what it is a way to take asynchronous and consistent snapshots of a generic distributed system. As applied to Spark, basically what we do is from the driver, there's a configurable period that says when it's ready to like start taking a checkpoint. And at that point, the driver will send a message to all of the tasks that are running, saying, "Hey, I need you to take a checkpoint." And what's interesting is this message is like injected into the data stream. So like the same stream that the records flow through. This marker flows through as well. We call it an epoch marker, and we call like the period between two checkpoints an epoch. By the way. So anyway, what happens with this epoch marker is as it flows through each operator, the ones that need to take a checkpoint, which not all of them do. For instance, a select does not need a checkpoint, but an aggregation does. So as this marker flows through the operators, when an operator sees it and needs to checkpoint, it takes that checkpoint, and then when it finally gets to the sink, so like the end of the query where Spark is writing the data back out to whatever it needs to go, the sink will record that it's received this marker, and then send a message back to the driver saying, "Hey, I got your message. This partition has completed this epoch." And then when all the partitions have completed the epoch, the driver will finally do a global commit for the entire epoch. And then basically what that does is we've constructed kind of a virtual batch. We even represent it in the same format as the batch checkpoint logs and microbatch queries. But basically what it says is the same thing. This range of data has been processed. It's definitely done with. I'll never need to go back to it. Yeah. So there's another detail there that's interesting, in that tasks are not like a one-to-one isn't the right term. Basically what I'm getting at is that they're a shuffle. So one task that's reading from a remote data source is not necessarily one task that's writing out to somewhere else. So there's a bit of work that has to go into how we make this work with a shuffle. So what we do is basically the driver injects the marker at each of the readers. The marker flows through all the other processing that happens in the reader task, and then it goes through the shuffle and gets to the other side. But the marker doesn't finish going through and make it into the reduced task on the other side of the shuffle until all of the readers that feed into it have successfully sent the marker. So at this state here, it'll pause for what should be a short amount of time, because all of the tasks are like running in parallel. It'll wait for all of the tasks to catch up, and then when that last marker finally does make it through the shuffle and to the bottom of the aggregation, they'll say, all right, that's finally in the aggregation task. It'll go through and it'll take a checkpoint for that aggregation operator, and then the writer will commit itself and send the message back to the driver. So the API for continuous processing, and as I mentioned before, it's really just structured streaming. It's the same queries you run. It's the same queries you run in a continuous mode instead of the microbatch mode. The only difference is what you currently do is specify like, we don't call it a microbatch trigger, but it is a microbatch trigger. You say at this interval I would like Spark to try to run a new microbatch, and we just have a different like Scala type there that says, at this interval, I want you to take a checkpoint of a continuous processing query. And nothing else about the query, nothing else about the query needs to change, and Spark will just kind of run it. So in 2.3, we had like the initial experimental release of continuous processing, and it supports ETL use cases, the kind of ones where you're like, I need to read a stream, apply a few transformations to the records, like clean up the data a little bit, and then I need to write it back. There are a lot of features that we're like working on adding now, but didn't quite make the cut. So for other use cases, it's not quite ready. We hope it will be ready. We hope it will be ready in 2.4 for broad use. Another limitation is we have a limited number of data source connectors to continuous processing. For complicated reasons, we couldn't completely reuse the microbatch ones. So that's another area of support we're looking to show up now. And so basically there's a big list of stuff that we know we need to work on, and are actively working on a lot of it. So we're working on a continuous shuffle operator. That's been my major area of focus for the past month or so. What makes this difficult is, as some people may have noticed when I completely glossed over it, a normal shuffle like waits for the map task to end before starting the reduced task. And that obviously will not produce like one millisecond latency. So we're working on like a new like continuous shuffle that doesn't block in that way. Yeah, we work on adding watermark support. Work on adding support for SQL metrics. A lot of the metrics we keep in Spark, like the number of rows processed, were like they aren't reported back to the driver until a task completes, and continuous processing tasks don't complete. So right now they're just not reported, and Spark says no, and like the Spark metrics say nothing has happened ever. So it's a bit unfortunate. We're working on a mode to provide exactly once semantics. This is a bit of an arcane thing. Basically, there are certain scenarios where if a query stops at the wrong time and you try to restart it, it'll restart from a place before it actually got to, and you'll end up with duplicated data in the sink. And yeah, there's a lot of like really fiddly things we have to do to make this not happen. And yeah, we have like some idea of what needs to be done. It's just another area of ongoing development. Yeah, and we're working on adding additional data source support. And ideally would be like mostly at parity with microbatch queries. And if you're interested in like the evolution of the APIs for how to integrate data sources with Spark, there's a data source v2 talk tomorrow, and that v2 is the API that we're going to be using here. That's it. Are there any questions?
All right, we can now take questions. Anybody got anything?
Hi. A quick question. So today, structured streaming would write multiple small files, which we have to compact later if this is our primary ETL into some table. So now with this continuous processing, would there be even more smaller files to compact for the price of getting data faster?
I hesitate to give a definite answer there because we actually can't write to files yet. It's a bit of an unfortunate limitation. I expect that the answer is yes. yes, in some sense. If you want to write larger files, you should be able to just specify a larger checkpoint interval, because each checkpoint will probably be able to write one file per partition. So there's still some coupling there, but it's not like it is in the microbatch case, where like if you want to write one file per hour, that means you can only run one batch per hour.
Hi. How are UDFs handled in this thing?
Sorry, I couldn't.
How are UDFs handled? Like user-defined functions in Spark streaming? Like, do you support the same Chandy Lamport checkpointing for them too?
Yes, yeah. Like things like mapgoose with state use the same like checkpointing mechanism as the internal aggregate functions. So they will like interact the same way. If you're writing like a completely UDF that like doesn't interact with Spark state handling, then you would need to do your own like handling of that. But I think it would be possible to write the logic if you needed to.
Hi. You know that one of the most difficult issues that we have right now to productionize machine learning models, as for example MLlib or things like that, is that we cannot do it in Spark. Would you think that this, for example, would be a nice solution to having a really responsive and time-performant HTTP API?
Well, what kind of responsiveness do you need? I'm not super familiar with the ML space.
Well, production size responsiveness. I mean, for example, right now, custom API should take around, I don't know, 2,000 milliseconds, for example. One of the issues that we have right now when developing and productionizing machine learning models is that we have to take the code out of Spark and then deploying it in another application, for example, using MLlib and many other tools. Right now, even in the dev list, there is a discussion open about how do we productionize these ML models and how can, and if it is or not a Spark issue, and if we should or not address that. Would you think that these kind of solutions, that continuous processing, would be a nice way or even a possible way to address this kind of issues?
I think continuous processing will help if you have a problem where it's like the latency is too high, or there's some like weird back pressure effects, because yeah. It isn't just a latency thing. There are like other artifacts in microbatches that sometimes end up like frustrating people and blocking them. The structured streaming data API will still be the same. That part isn't really changing for continuous processing. So most issues with productionization that have to do with like how you integrate with the API and not just like what kind of performance characteristics you're getting. I don't know that those would necessarily be addressed here.
All right, any further questions? Okay, here. We can probably do one or two more questions.
Is state limited to on-heap memory available?
Sorry?
Is state limited to the on-heap memory that's available, or does it spill to disk?
It does spill the disk. Yeah, it's more complicated than that, because it doesn't always spill the disk at the right time. So there are situations where you have to like debug. Oh, the state store has run out of memory, but the state does spill it. The state does spill that it does spill the disk. It's definitely not limited by the amount of memory you have.
And when checkpoint happens, it's copied off the box for recovery.
Yes. It is committed for recovery.
Okay. And is the back pressure similar to the PID controller in microbatching, or is it different?
So the back pressure is one of the things that one of the things that we're working on now, basically because it's like a new execution system, we're not entirely sure on what needs to be done to provide an acceptable amount of back pressure. What we have now is basically just like bounded queues on task boundaries. So things will like block before forwarding more data. But yeah, this is an area of active investigation. So yeah, if anyone has ideas about how this should work, the dev list is very open to discussion here.
All right, so it seems like we still have a lot more questions, but I know that we are running up against the limit of our time. Why don't we have everybody go ask those questions of Jose outside so that we can get on to the next speaker and get everybody cycling through. But before we do that, can we have one last round of applause?